Good evening. Today's quote is by Will Rogers. Don't let yesterday take up too much of today. It's a good one. Don't let yesterday take up too much of today. Today's word is ominous, suggesting that something unpleasant is likely to happen. There was an ominous silence. Question 5. Find the value of. We are going to discuss first one. Please do not write, just listen to me. But please do write the solution after the lecture. You are asked to find the value of x cube minus x square plus x plus 46 if x is 2 plus 3i. You may say, sir, what is the big deal? Replace every x by 2 plus 3i. Yes, that method is correct. But if it is x raised to 6 or x raised to 7, will you find 2 plus 3i raised to 7? No. So we are going to discuss shortcut method. Let me explain. X is given to be, see this type is important from exam point of view. X is 2 plus 3i, so x minus 2 is 3i square. So x minus 2 square is 3i square. That is x square minus 4x plus 4, 9i square, but I square is minus 1, so minus 9. Now rearrange the terms to get x square minus 4x plus 13 equal to 0. Now we have to find the value of this expression. Don't call this as an equation. This is an expression. So we divide this expression by x square minus 4x plus 13. I hope you know how to divide. Working rule is simple. Highest degree term in the dividend is x cube. In the divisor it is x square. X cube upon x square is x. So in the quotient I will write x. Now multiply these three terms in the divisor by x. So x cube minus 4x square plus 13x. We subtract. So on subtraction we get 3x square minus 12x. Bring this term. So it is 46. Now 3x square upon x square is 3. So 3 in the quotient. So 3x square minus 12x plus 39. Again subtract. These two terms get cancelled. So what remains is 7. Now by division algorithm, we have dividend equal to divisor into quotient plus remainder. So this is nothing but divisor is x square minus 4x plus 13 into quotient into quotient x plus 3 plus remainder. But this is 0 from 1 and therefore final answer is 7. Now here I know you will not ask, but a question can be asked. See, this is 0, right? So you may ask me, how can we divide by 0? The answer for the same, for the question you haven't asked, is I'm not going to write x square minus 4x plus 13 in the denominator. See, writing 0 in the denominator is not valid, is not allowed. I'm writing everything in the numerator. In other words, I have expressed this in terms of x square minus 4x plus 13. Why in this form only? Because I know value of this expression is nothing but 0. Okay, so what is the final answer? Final answer is 7. I'm going to tell you shortcut method also. So shortcut method, till x square minus 4x plus 13 equal to 0, it is same. Basically, this is division only, but it is called as indirect division. We know that in direct division quotient is x plus 3. See, this is x cube. So I write x into what? I am not saying taking x common. X into what? I have to use this fact that value of this is 0. So I write what I want. But then I must obtain what is there. X into x square is x cube. Present x into minus 4x is what? Minus 4x square. But it is minus x square. To make hisab barabar, I must add 3x square. Okay. X into 13 is 13x. But it is not 13x. It is x. So minus 12x. Then why 46? Because it is present from the beginning. We are writing equal to sign. You can verify if you open all the brackets. You will notice that you have written the same and that is required. How can you write different thing? Okay. Now what is the advantage of this? See, value of this is 0 from 1. So x into 0. Now from these take 3 common. First I write what I want. So I have written that. But then I must obtain what is there. 3x square present, minus 12x present, 3 into 13, 39. It is 46. So from 39, how to get 46? Plus 7. Now this is 0. 3 into 0, 0. So 7. See, the method is the same. This is called as indirect division. Because if you take x square minus 4x plus 13 common, here you get x plus 3. See, quotient is x plus 3 only. Is that clear? So anyway, we are going to use this division method only. Now, x is second one. We are asked to find value of 2x cube minus 11x square plus 44x plus 27 if x is 25 upon 3 minus 4i. Okay. Now, x is 25 by 3 minus 4i. Multiply numerator and denominator by 3 plus 4i. So, there was some disturbance, so I'll explain from the beginning. Second sum, find the value of 2x cube minus 11x square plus 44x plus 27 if x is 25 by 3 minus 4i. See, multiply numerator and denominator by 3 plus 4i to get x equal to what? 25 into 3 plus 4i upon 9 minus 16i square, but I square is minus 1. So 9 plus 16, that is 25, which gets cancelled with this. So effectively what is x? 3 plus 4i. So what is x minus 3? 4i. Now square. So x square minus 6x plus 9 equal to 16i square. I square is minus 1. So minus 16. Therefore, x square minus 6x plus 25 equal to 0. Okay. So we have to make use of this fact. Now, I will say we will use division method, direct division. Let us divide that expression. You have to write. Let us divide 2x cube minus 11x square plus 44x plus 27 by x square minus 6x plus 25. I hope you can perform this division. So x square minus 6x plus 25, and this is 2x cube minus 11x square plus 44x plus 27. Working rule is simple. Divide 2x cube by x square. So 2x. So in the quotient, I will be writing 2x. Multiply all the three terms by 2x. So it is 2x cube minus 12x square plus 50x. Then you have to subtract. So what is the remainder? It is x square minus 6x. Now we bring 27 and write here. Now x square upon x square is 1. So in the quotient it is plus 1. So x square minus 6x plus 25. Now you have to subtract this, same as in the previous case. Okay. So what is the remainder? Remainder is nothing but 2. And then you have to say, therefore, Actually, by you have to write by division algorithm we have, but here I will write directly. Therefore, 2x cube minus 11x square plus double 4x plus 27 is that divisor x square minus 6x plus 25 into quotient 2x plus 1, okay, plus remainder. Actually, it is not proper to say divisor equal to 0. Value of this expression is 0 multiplied by 2x plus 1 plus 2. The reason for this, from 1 value of this expression is 0. So what is the final answer? Final answer is 2. Right up. Third is for homework. Answer is 7. Fourth one, x is minus 5 plus root minus 4. That is minus 5 plus root 4 into root minus 1, which is I. So x is minus 5 plus 2i. That is x plus 5 equal to 2i. Square, you have to actually write that on squaring. So x square plus 10x plus 25. 4i square, that is minus 4. So x square plus 10x plus 29 equal to 0. Now, actually, you should say we divide that expression. What is that? 2x raised to 4 plus 5x cube plus 7x square minus x plus 41 by this. I will show you division. X square plus 10x plus 29. This is divisor. And this is dividend. X raised to 4 plus 9x cube. You have to be very careful. In some cases, one of the terms is missing. So you have to write that. Suppose x cube is missing. You have to write it as 0x cube like that. But here it is not missing. It is given to be 9x cube. So you have to write that minus x minus 4. Okay. Good. Now, same working rule. Highest degree term x raised to 4 should be divided by x square here. So in index, I will write x square. Okay. Multiply 3 terms in divisor by x square. So x raised to 4 plus 10x cube plus 29x square. Subtract. So that gives me minus x cube. You have to be careful. Plus 6x square. Bring minus x and write it after 6x square. So it is minus x. Again, same logic. Minus x cube upon x square is minus x. So I have to write minus x in the quotient. So x square minus x. Multiply these 3 terms by minus x. So minus x cube. See, we have to take care of this one. This should get cancelled. Not sure about remaining 2. They may or may not get cancelled. Then minus 10x square minus 29x. Subtract. So that gives me, just check this, 16x square I am getting. Is it? 16x square plus 28. Why 28? Because minus x plus 29x is 28x. Bring 4 and write it after 28x. And the last part now. So 16x square upon x square is what? 16. So plus 16 in the quotient. And here it will be 16x square plus 160x it is. 160x. Okay. Now tell me what is 16? 16 into what? 16 into 29. What is 16 into 29? Is it 464? Just check this. Yes. So subtract. What is remainder? Now you may say, sir, this is wrong because remainder is not coming 0. Who says it should be 0? Not necessarily. Just check this. minus 132x minus 460. Okay. So what is difficult? Division. So value of this expression, what is that? 2x raised to, what is that? X raised to 4 rather, I'm sorry, not 2. Plus 9x cube plus 35x square minus x plus 4. This is nothing but divisor. So x square plus 10x plus 29 into quotient x square minus x plus 16, okay, plus remainder, that is minus 132x minus 460. Now this is not the final answer. See, this is 0, 0 into this x square minus x plus 16. Note that what is x? You have to substitute the value of x. See, answer is a complex number. It should be of the type a plus ib. So it is minus 5 plus 2i. So I have to write that minus 460. The reason for this step from 1. Okay. So this is nothing but 0, then plus 660, just check this, okay, minus 264i minus 460, is it? And therefore the answer, the value of this expression is 200 minus 264i. Right down. Take your own time. Fifth one is for homework. Answer is 6. Now the next important part is Aragon diagram. Aragon is actually name of French mathematician. Credit of representing a complex number on complex plane is given to this French mathematician. We know that real numbers can be represented by points on a line. And how to do that? In such a way that the corresponding to every real number, there is one and only one point on the line, and corresponding to every point on the line, there is one and only one real number. Similarly, we can represent a complex number. How? Consider any complex number, say this is z, z equal to x plus iy. Instead of a plus ib, I am using x plus iy, where x and y are real numbers. And what is I? Root of minus 1. Now draw the coordinate axis. Since x is a real number, x can be represented by what? The point x0 on x-axis. Y, though we call it as an imaginary part, it is also real. So it can be represented by the point 0y on the y-axis. See, I'm drawing this. So this I can say this is x0, this is axis of reals, and this is axis of imaginaries, right? So this is the point I can say 0y. Okay, so this is nothing but xy. I hope you are getting this. Okay, since y is again real number, y can be represented by the point 0y on the y-axis. Then the point pxy, I will say that this point is what? Pxy. I will use dotted line for this. Then the point pxy is said to represent the complex number x plus iy. So here complex number x plus iy is represented by the point P in this particular plane. Now, as I said, x-axis is called as axis of reals and y-axis is called as axis of imaginaries because that imaginary part y is represented on y-axis. Such a representation of complex numbers by points in a plane is called Arrhenius diagram on complex plane. I repeat this. Such a representation of complex numbers by points in a plane is called Arrhenius diagram on complex plane. Now, can you tell me if the complex number is 3 plus 4i, how will you represent it? Yes, it can be represented by the point 3, 4, right? I will write complex number here. Suppose it is, as I said, 3 plus 4i. It can be represented by which point? 3, 4. Suppose complex number is minus 7i. Now minus 7i can be written as 0 minus 7i. So it can be represented by which point? 0 minus 7. If I consider one more point, say 3 by 4i minus 11, then don't say the point is 3 by 4 minus 11. The point is minus 11, 3 by 4. Okay. So in short, what is Arrhenius diagram? Representation of a complex number in a plane or by a point by an ordered pair. So this is nothing but Arrhenius diagram. What can you say about complex number 0? 0 complex number will be represented by origin. Why? Because 0 complex number is z equal to 0 plus 0i. Simple, right? Now, we are going to discuss two important terms. Let me explain first, then I'll solve your difficulties. This is an important concept, modulus of complex number z. Suppose z equal to x plus iy is a complex number. Then modulus of z is defined. Listen to the word defined. The modulus of z is defined to be root x square plus y square. And how modulus of z is defined, or rather is written, it is mod z, right? So mod z is root of x square plus y square. You can write this as MOD, standard short form of modulus, mod z. So if z is say 6 minus 8i, can you tell me modulus of this? It is mod z equal to root of, I will write directly, what is square of 6? 36. What is square of minus 8? Not minus 64 plus 64. So it is root 100, that is nothing but 10. Now my question is, can you interpret modulus of a complex number geometrically? I repeat the question. Can you interpret Z geometrically? Now, before telling you the geometrical interpretation of that modulus, let me tell you about an argument which is also called as an amplitude of complex number z. Suppose z is x plus iy. We have just seen that this complex number can be represented by the point pxy in Arrhenius plane. Suppose angle XOP equal to theta, then this theta is known as an argument or an amplitude of a complex number. Actually, in the textbook, they say that 0 degree less than or equal to theta less than 360 degrees, or if you say in the radian, then it is 0 less than or equal to theta less than or equal to 2 pi. Basically, we know that there can be number of revolution or complete rotation. This is theta. Then 2 pi plus theta is again the same angle. 4 pi plus theta is again the same angle. So there can be number of different arguments. But when we say an argument, we should consider only particular interval. It is called as principal argument. Let me explain first. I'll solve all your difficulties. And for that, unfortunately, this is not mentioned in the textbook. For that, what is the restriction on theta? I'll show you diagram also for that. Minus pi less than theta less than or equal to pi. That is, answer should lie between minus pi is not included to pi, which is included. Let me show you this. See the diagram. Just a minute. Now, complex number lies in first quadrant. I hope you can see the diagram. So if Z lies in first quadrant, clearly theta lies between 0 and 90 degree. Here you will notice that theta is in second quadrant. So theta is greater than 90 degree but less than or equal to 180 degree. Now see the case. Theta lies in which quadrant? Third quadrant. Note that angle is measured in clockwise sense, right? So it has to lie between minus pi to minus pi by 2. Okay, see, minus pi means this one and minus pi by 2 means this one. And if this Z lies in fourth quadrant, that is point representing the complex number lies in fourth quadrant, then what are the restrictions? Minus pi by 2 to 0. This is 0. This is minus pi by 2. Okay. So minus pi by 2 less than or equal to theta less than 0. But you will notice that in textbook, they have just mentioned this 0 less than or equal to theta less than 2 pi. Now you will ask me then which answer we are supposed to write. We have to follow textbook only. But in higher mathematics, you will notice that an argument means principal argument. Its value lies between this minus pi less than theta less than or equal to pi. In fact, from this diagram, we can say, I hope you will understand this. We can say that what is cos theta? See, this much, if I complete the triangle, then this much is x and this much is y. What is cos theta? Cos is adjacent side x upon hypotenuse. Note that I was talking about that geometrical interpretation. What is OP? Distance of the point PXY from origin. We have done this section distance formula. It is root of x square plus y square. But we have just defined this as modulus, and that is why cos theta is x upon modulus z. Similarly, what is sin theta? It is opposite side y upon hypotenuse, which is nothing but mod z. Now, if you take the ratio, then what is tan theta? It is y upon x. And from this, they say theta is tan inverse y upon x. But again, we haven't done that part. So what we are going to do is, we are going to write values of sin theta and cos theta. If we come across values like tan theta equal to minus 1 upon root 3, then we can find the exact angle. Otherwise, we will keep answer in the form of sin theta and cos theta. Okay. Now, I have already told you now geometrical interpretation of modulus. See, if z equal to x plus iy is a complex number, then it is represented by the point pxy. And what is distance of pxy from origin? 0, 0. Use distance formula. It is root of x square plus y square. But see, root of x square plus y square is defined to be modulus z. So if someone asks you, what is the geometrical interpretation of modulus? Your answer should be modulus represents the distance of the point representing that complex number from origin. I repeat, what does modulus of z, that is complex number z, represent? it represents the distance of the point representing that complex number, that is x plus iy, from the origin. And what are the coordinates of that point? They are x comma y. Exercise 1.3. Actually, we will be solving first and second also, but let me explain third one. Just listen to me. If z equal to 3 plus 5i, this is simple one, then represent z, z bar minus z bar in Arrogance diagram. Now z is what? 3 plus 5i given. So it is z bar, that is conjugate of this complex number, 3 minus 5i. To get conjugate of a complex number, we have to change the sign of imaginary part. What is minus z? Minus 3 minus 5i. And what is minus z bar? It is minus 3 plus 5i. Now this part is not at all difficult. Z is what? 3 plus 5i. So it can be represented by which point? A, 3, 5. You can name this point as P also. What is important is coordinates 3, 5. What is z bar? 3 minus 5i. So this can be represented by which point? 3 minus 5. Simple. Then minus z is minus 3 minus 5i. Can be represented by which point? C, minus 3 minus 5. Finally, minus z bar is minus 3 plus 5i. Can be represented by the point, D minus 3, 5. See, this is the diagram. See, A, B, C, D. These are the 4 points. Okay, I'll zoom this. See, this is the point A representing Z. This is the point D representing minus Z bar. This is the point B representing Z bar. And this is the point representing minus Z. This is from exercise 1.3. First question, find the modulus and amplitude of the following complex numbers. First is 7 minus 5i. Usually complex number is denoted by z. So z equal to x plus iy equal to 7 minus 5i. So it is modulus of z. It is root x square plus y square. So it comes out to be root 74. Now the amplitude theta is given by what? Sin theta is y by mod z, that is minus 5 by root 74. Cos theta is x upon mod z, 7 by root 74. So tan theta is minus 5 by 7. You will find that they have written theta as tan inverse minus 5 by 7, but we haven't done inverse function yet. But you will agree that the principal argument for that minus pi less than theta less than or equal to pi. So you can write that minus pi by 2 less than theta less than 0, because the point representing that complex number lies in which quadrant? Fourth quadrant. Okay, write down. Z equal to x plus iy. Second sum we are doing root 3 plus root 2i. So modulus of complex number mod z is what? Root of x square plus y square. Now it is a square of root 3, 3. Square of root 2, 2. So it is root 5. This is modulus. Okay. Now amplitude theta is given by, you may write tan theta. What is tan? It is sine upon cos, or I can say y upon x directly. So what is y? Root 2 upon root 3. Just write this much. I can show you this diagram. Just a minute. See, the point is in which quadrant? Root 3, root 2 representing complex number in this quadrant. So it is better if I say 0 less than theta less than 90 degrees, that is pi by 2. So this is about complex numbers amplitude, which is also called as an argument. Third is for homework. What is the actually I should say modulus of z. Complex number is minus 8 plus 15i. So mod z is root 64 plus 225. That is root 289. That is 17. Tan theta is minus 15 by 8. Let me explain. Z is actually minus 8 plus 15i. So it can be represented by which point? Minus 8, 15, second quadrant. That is why I have written theta is greater than 90 but less than 180. We cannot find exact angle because we know tangent ratios of some particular specific angles. Of course, using log tables we can find. Okay. So that's it for today.